thank you for sticking with me with not one, but two presentations. But in my defense, I try to make them interesting, and I hope they will be useful to you. So, yeah, let's start with the first one. Now, like, there is a different profile of people. You may be working with RAG already. You might be experts. You may not even heard about the RAG. But I try to make this relevant for wherever you are in that bracket, basically. So, this agenda is very simple. I will talk about RAG and our take on the RAG, and basically about the challenges, where I would pinpoint one specific challenge, chunking, that maybe doesn't have that much spotlight, but I find this one the most interesting. And finally, I will briefly show you Infobip product for the RAG and the analytics that are specific to the RAG. So let's start. So first, what's Retrieval-Augmented Generation? For those that don't know, for those that know, please bear with me for a moment. So, well, it's an architectural pattern that lets us connect our data with LLM. And the different approach would be to fine-tune an LLM with our data, which in most cases doesn't really make sense. And even when we do fine-tune an LLMs, we would again run the Retrieval-Augmented Generation on top of these fine-tuned LLMs, because this would actually give us usually better response quality. And the way this works is we start with some data set, which has some files, and what we would do, we would break these files into some small chunks, which would be turned into vectors and stored in some vector store. And the reason we do this, well, the number one problem for unlocking LLM performance is how do we feed exactly relevant data at just the right time? So this is like a critical challenge. And I guess nothing much changed in machine learning, so it's still about the data. But okay, let's say we now took this data, turned it into vectors, stored this. So what happens now is, let's say we have a user asking a question such as, what is the price? Well, what is the price of what? And hopefully somewhere in the chat history, there is something like, for example, what is answers, that, you know, this what is price makes sense. So the first step that needs to happen is you need to have something that is going to look at the chat history and the current question and somehow rewrite this. And if you're thinking, well, LLM should understand this, yes, but the retrieval will not. So we do this to actually optimize the retrieval, which is entirely based on the vector search. And let's say that we now modify this, what is the price, into something like answers price, or what is the answers price. So we would embed this, again, with the same algorithm we used in the chunking, and find the top M documents, let's say 10. So the next step, and this is a really critical step, is that we would re-rank this with something like a cross-encoder. We would feed into this cross-encoder model the modified query and these top 10 chunks. And then the cross-encoder should return us the actual 3 most relevant chunks. And here is one thing that we do somewhat differently than what I've seen people usually do. So we feed these re-ranked chunks into LLM, but we now ignore this modified query. We go back to the user's query, which was, what is the price? And the history. So we expect that LLM, you know, is able to figure out what is the price to what it refers to. And why don't we use the modified query? Well, sometimes it's going to be hallucinated. It might be some mumbo jumbo, let's say 1% of the time. And then for this 1% of the time, we don't want LLM to reply to some nonsensical question because it didn't see the actual question. That's why we use query basically when using the LLM, but for the retrieval, we use this modified query, which is optimized for retrieval. So this is the basic setup. There are more things happening, but like high-level idea. And what's really interesting when we think about the LLM applications today is this trade-off between the latency, quality, and the cost. And it's never been more pronounced in the software development as it is today with LLMs. So it's very hard to optimize across all 3 axes. And to show you one example, we have a different product called Multimedia FAQ, which does 2 things. So first, it's there to solve the multimodal search, which is actually less important. The more important is that we feed data here that should never be used in the RAG pipeline. So this is a highly specific data, let's say very sensitive procedures which have 10 steps. And our customers insist that this reply must look exactly from step 1 to step 10. You must guarantee that nothing is changed, like banks might have some very, strict policies or refund policies or stuff like that. So this product is doing that. So it's running the vector search, a fairly complicated pipeline, and then when it gets result, it's using some kind of a classifier and LLM, which is there to prove that the chunk that we would retrieve is actually relevant, but we don't generate anything. We retrieve and try to prove this is actually relevant. If it's relevant, we return this to the end user. But let's say it's not relevant, and we spent maybe 1.5 seconds to compute this, and then now we trigger RAG pipeline because we haven't found anything. And now this first step, this multimedia FAQ is much cheaper than the RAG. And then, okay, so we now triggered the RAG, but now we need to wait for the RAG pipeline as well. And this may take another, let's say even 3 seconds. And then when you have CPaaS layers, so the end user is waiting for 5 seconds. But the benefit you get is that this is cheaper than if we did something like this. What if we ran these two things in parallel? Well, now we, again, compute the multimedia and RAG in parallel, wait for a result, and we trust more in the result of this multimedia FAQ. If we can prove that the result is valid, we return it. But if it's not valid, we already started RAG computation, so we will wait no longer than 2 or 3 seconds. So these kind of engineering things that can actually make a huge difference in the CX, basically. And let's say you have a guardrails. Do you want to first compute the guardrails and then start the pipeline? Or you should be optimistic that most requests will be saved. So maybe you should also run that in parallel. And this can actually differentiate your product a lot. You know, if you think about going to the bot, which takes 7 seconds to reply, or one that takes maybe 2 seconds. But the cost of running things in parallel and discarding results will be obviously higher. And there are many other variables like which LLM are you using? Is it self-hosted? And the same question can be asked for embeddings. Which re-ranker are you using and what kind of compute you are dedicating? Are you using some super expensive GPU or are you using some small GPU for that? How are you doing the guardrails and this multi-turn optimization? How are you basically rewriting queries? Or are you doing query expansion? Like sometimes if user writes tomorrow, that means nothing for the retrieval system. You need to map tomorrow to some ISO date. When you add the CPaaS layer on top, well, it adds latency. So we need to be really smart. You know, what are we actually doing with RAG system? It should be configurable. Some clients care about cost, some don't care about the cost at all. So not at all. Well, they're less sensitive to the cost. And I know, so there is like people say the AI price goes down, but somehow our AI bill keeps increasing. So that's interesting how the cost actually go down. But I just linked 2 studies over here, and they really need to be taken with. They need to be read carefully, but I did put the titles over there. What's actually true is that currently there is a 600 billion of a difference of investment in AI with respect to the revenue being generated. And it's a pretty serious question because like a few months ago it was 200 billion and it keeps going up. So the NVIDIA is making profits, but everyone else. And like another article from MIT from just a few days ago where they say that 95% of enterprises generate zero return of their 30 to 40 billion cumulative investment. So kind of makes you wonder, you know. And they actually give some hints how to be in this 5% which actually generate the revenue. But maybe the final thing to consider is if you, for example, this is the pricing from the OpenAI official pricing. So if you look at this GPT-4o mini, so this was the price for the input and for the output. And this is the price for the GPT-5. So this is a 2-fold increase almost, and this is more than 3-fold increase. And the prices are going down, right? And then you have just, you know, these 3 pieces of equation. So that's why I think this cost axis may be more important than people actually think, especially when we are talking how do we get revenue back. All right, so let's just talk about one more kind of more technical thing. So how does that retrieval usually work? Well, there are a couple ways that people tend to approach retrieval. I would say all of them are not usually necessarily the best. So the first one is you have a large data set, and the key is large, and you break it down into n clusters, let's say 4, and then you would have a centroid, which is the best representation of the cluster. So when the query comes in, a user question like what is the price, you would find maybe top 2 most closest centroids, and you would only search in these clusters. So this would speed up computation like a 2-fold, which is cool. So you get better computation, but you may not necessarily always guess the correct cluster. So sometimes you will have a miss. It's going to have an impact on recall. That's an approximative search. And another approach, this one is a bit more involved, The way this works is you have data set vectors, you would break them into subvectors, and then you would cluster each subvector independently. And then you can take data points, and instead of writing these subvectors, which will typically have dimensions with floating points, you would just write the nearest cluster ID, so the centroid ID. And what this does, unlike this approach, it saves memory considerably. So 30, 60 times it can save memory because you no longer need to use floating points basically in every dimension. You can just use 4 8-bit integers. So in test time, you just need to know the exact representation of the centroids. But I'll skip the inference how it works, so it's technical. And then the third approach, the third approach is something that's actually the state of the art. Wrong button, but sorry. Yeah, so this AgenSW, commonly used, it's again approximative search. So it's a greedy graph search algorithm. You start from sparse layers and then you move to the more dense layers. And what you do is you keep making progress to this graph as long as the distance is getting shorter until you can make no longer progress. And that's all very cool and great, but each of these approaches will have a massive hit on your recall. Or you will end up returning many more chunks than you need, and then you will feed noisy data into the LLM. But what people don't usually think about is that this can be enough. So a simple brute force search will have a perfect recall rate. And I have never, and I have looked at like 12 RAG pipelines, I have never seen people using this. So they would lose like 10, 15 points of recall for 100 vectors. And you can basically search 50,000 vectors in 7 milliseconds on a reasonable CPU. On GPU, this is even faster. Why would you lose 15% of recall for 7 milliseconds? So yeah, I don't like, if you are a researcher and you have, this is like a linear complexity and well, this is logarithmic. Yeah, no, but it's 7 milliseconds. So yeah. And maybe just to talk about one more thing. So these are chunks from Gartner, 3 different reports. And what Gartner is talking about, well, the companies and organizations still didn't involve with respect to the data management, so nothing moved much, and they are certainly not up to date with the Gen AI requirements. So they estimate that 60% of AI projects will abandon because their data strategy is not up to date. And they are talking like about things like RAG and chunking. I'll talk about that soon. You know, that these are the tricks that can help us to be more AI data ready. And then another thing that's interesting is that, well, actually this one, it takes 8 months to go from AI prototype to production. You can stitch software fast with AI, but when you actually need to tune these prompts and everything to work correctly and these agents, it takes a lot of time. And these are the problems that are super interesting for us. And, you know, we are tackling exactly these problems. So I talked earlier about the chunking and how we can break documents into chunks and store them into vector stores. And I think this is key challenge for RAG, how you do this. So there are a couple of approaches. Like people are sometimes using LLMs, they feed data, and can you break this into some sane chunks? The problem with that approach is, well, what if the LLM changes refund policy, or there is no refund policy in the document and then it adds it? If we were to do this, and it changes refund policy from 5 days to 7 days, we are accountable for that. So this is definitely not something we can do on behalf of our client. The most commonly used approach is fairly naive, where you have fixed size token windows. You say, well, let's just chunk this document every 500 tokens, and I'll show the problems with that. And there are other chunkers that use semantic similarity that has its own problems, hyperparameters, it rarely works. And to illustrate what can happen on this one example, so we sometimes crawl data from the website for our clients, and we obviously cannot write one web crawler that's optimal for every website in the world. And let's say that this is on the homepage of some insurance company. So at a glance, nothing wrong with the text, but there are actually 2 problems. If we, let's say, create one chunk out of this, it actually embeds 3 different topics: Casco, life insurance, and travel insurance. So the first problem is, if I ask about the life insurance, there is basically no guarantee that vector search will even find this chunk because it actually has information about travel insurance and Casco as well. So that's a problem number 1. And then the problem number 2, if you are using something like a token count chunker, Well, it can create chunk that maybe starts from here. Simply submit photos up to here. And then I can ask something like, how long do I need to wait for life insurance claim settlements? Well, guess what? It doesn't see the Casco at all. So it will be happy to tell you, well, it's within 14 hours. And this is the most common source of hallucination that I have seen in RAG systems. Basically, it's basically what you do with these chunkers. And what I can tell you for this, what we did, so this took considerable effort on our side to build, is that we have actually built a chunker which has an interesting property. It's guaranteed that it will never modify your data. It can fail, even though it fails, it will tell you I failed. But let's say over 95% of the time it will succeed. And if you retry it, it will likely succeed on the second try. But what it does is, for example, this is just a small snippet. This is 30 pages of pharma document, and this is also like 20, 30 pages of some telco document. As you can see, like this is a perfect chunk. So it's an immunosuppression and risk infection, so it's related to that. And this is another chunk, which is also something that's a standalone topic and something like this. And similarly over here in the French. So this actually works in most of the languages, and we have this available as an API. If you're building your own RAG pipelines, we can even give you this currently for free if you want to experiment with that. And we really, we tried everything, and the reason we built this is because our professional services were manually adding these nodes. You can imagine that it took months, to process these documents. So when we started building this, we wanted to get something that is somewhere below human level performance, but we now see that it's actually better than what a human would annotate. And how did we evaluate this? Well, it's actually very difficult to evaluate chunkers. So the people usually do, I have a question, and these 3 chunks are relevant. And then I change the chunking algorithm, and all my labels are off, because I expect different chunks. So we did something different. For every question, we went to documents, and we marked sentences which must be returned, irrespective of chunking algorithm. So the minimum information, the key information that must be in the retrieved. And we noticed when we used just ADA3 that with noisy, with crawl data, it's just 72% recall. But when we use this with cross-encoder, it went to 94.5%. So I can show you actually a quick demo of, well, the portal went down. There is an incident right now, so I can only show you analytics. I wanted to show you the RAG tool, but now this wasn't. Yeah, okay, let me show you this actually first. So I didn't talk about this in presentation, but the thing with RAG is, well, you deploy it, and what then? Does it work? And if it doesn't work, why it doesn't work? And this is work in progress, so we will make a major changes in the next 2 weeks on this UI. And there will be many more of these categories. It will be far more granular. But what you can see, for example, if we examine this not documented category, this tells you, well, there is a 31 example of users asking about delivery location, and your bot doesn't handle this. It's rejecting this. I am unable to confirm. I'm sorry, but I cannot assist. I'm sorry, but I cannot assist. So what you basically can infer from this, well, you need to add something about delivery location update, because there are 31 examples out of these 616 where the bot is simply refusing to talk about this. And the topic is relevant, And this improved documentation, this is actually maybe not necessarily the best term, but this is where we usually have hallucinations. So the bot replied, but the answer is not grounded into the data. Anyhow, I'm just showing you a prototype. So in the next 2 weeks, we expect many more features over here. So I would, with that, actually conclude this first presentation while you still have any kind of attention. So if anyone has questions, thank you.